Okay, so the standard loop coaster questions that I asked you to try. This is what the picture looks like. This is really what the picture looks like. How fast is the roller coaster car traveling at the bottom of the hill? So it's changing height. We're looking for its speed down here. So you're going to use energy. 1/2 m v initial squared mgh initial 1/2 k x final squared equals 1/2 mv final squared mgh final 1/2 k x final squared plus E lost. And so in these questions, you can assume they're frictionless. There's no spring. At the top, it has both a speed and a height. And at the bottom, it has a speed, no height. And we're looking for this speed. So I would divide everything by m and multiply by 2, right? Because if we divide by m, this m goes, this m goes, this m goes. So you would have 1/2 v initial squared plus gh initial equals 1/2 v final squared. So multiply everything by 2, and you get v initial squared plus 2gh initial. Fill in your numbers. V initial is 10 meters per second. Squared should be about 100, plus 2 times 9.81 meters per second squared, times the height is 80 meters. Remember, that'll be VF squared, so 80 meters, 788 times 2, 150, 1,562, 1660. Take the square root, 40.86 perhaps meters per second. Okay, that's part A, the speed at the bottom. Then it says, how fast is the roller coaster traveling as it enters the loop? So just because this picture is better. So at the bottom, we found it to be 40.86 meters per second. And then it says as it enters the loop, well, that's still the same height. So it's still going to be 40.86 meters per second. So the answer to A and B are the same. Or 1 and 2, excuse me. 1 and 2. So number 3 says, what is the centripetal acceleration applied by the track at the bottom of the loop? So you're looking for AC, and we know AC equals V squared over R. We just found the V, 40.86 meters per second, and R, it told us in the question, is 20 meters. And remember, this is squared. So AC should be equal to 83.4 meters per second squared. Okay? It's 4.8, I think. Sorry, I had to go looking for 4.8 meters per second squared. And then number 4 says, how many G's does the rider feel at the bottom? So if you remember what we did to figure out the number of G's felt, whether it's at the top or the bottom, it's AC divided by G. And then depending on where it is, you have to decide, are you adding or subtracting? At the bottom, you're adding. So 83.48 meters per second squared divided by 9.81 meters per second squared. And then you're going to add 1 to that. And you should get 9.51. G's. You get 8.51 in this part, and then 1. All right. Number 5 says, how fast is the roller coaster car traveling at the top of the loop? So up here, I would do energy again, because you've changed height, which means you're changing speed. So 1/2 mv initial squared, mgh initial, 1/2 kx initial squared equals 1/2 mv final squared. mgh final 1/2 kx final squared plus E lost. Again, no E lost, no spring. Up here at the top, my final, it's going to have both a height and a speed. And if we pick our beginning as the initial again, both a height and a speed. So again, the m's will cancel. We're looking for V final, so I'd bring this term over. So it'll be 1/2 V initial squared plus GH initial minus GH final equals 1/2 V final squared. Multiply both sides by 2. So V final squared will equal V initial squared plus GH initial minus GH final. So 10 meters per second, squared, plus 9.81 meters per second squared times 80 meters minus 9.81 meters per second squared times, and the height at the top of the loop should be 40, right? Because the radius is 20, so the height would be 40. Remember, that's going to be VF squared, so you're going to take the square root, and when you do, you should get 29.75 meters per second. Okay? Then the question that was 5, 6 says, what is the centripetal acceleration? So you're going to do AC is equal to V squared over R. So 29.75 meters per second squared over the R was 20 meters. And you should get an AC to be 44.24 meters per second squared. And then number 7 wants to know how many G's does the rider feel at the top. So remember, number of G's felt at the top is AC divided by G, and at the bottom it was +1, at the top it's -1. So 44.24 meters per second squared divided by 9.81 meters per second squared -1. And when you do this, you get 3.51 Gs. And then the last part wants to know how fast is the roller coaster traveling at the top of this hill. So it's going to be energy again. I might have room enough to do it up here. So number 8. So 1/2 mv initial squared mgh initial 1/2 kx initial squared equal to 1/2 mv final squared mgh final 1/2 kx final squared plus E lost. So this is identical to number 1 and to number 5. No E lost, no spring. You're looking for the final speed. The m's are going to cancel, so it'll be 1/2 V initial squared plus GH initial minus GH final equals 1/2 VF squared. So VF squared is going to equal VI squared plus 2GH. I'm just realizing I didn't put a 2 in down there, I don't think. 2GF. But I did have the right answers. I put the 2 there. I lost the 2's here. But my numbers are right. Because I did it earlier and put the 2's in. Sorry about that. Don't forget your 2's. And now fill your numbers in. So VF squared is equal to 10 meters per second squared plus 2 times 9.81 meters per second squared times 80 meters minus 2 times 9.81 meters per second squared times 35 meters. Don't forget to take the square root, and when you do, you should get 31.35 meters per second. Sorry about those 2's down here. Did the answer earlier, so that's why I know that the answer I have is not based on the numbers I had written here. It was based on the numbers I did earlier where I had the 2's in. Okay, so now I would like you to go to the next sheet, which is the irregular loop. And I want, because if you notice, the number of G's felt here is 9.15. And if you remember, we said can't be over 8 or you're in trouble. This loop is not a good loop. And so we switched to what's known as an irregular loop. And so in the irregular loop, there's 2 circles. This one has a radius of 50 meters, and this one at the top has a radius of 10 meters. Okay, and everything else is the same. So I'd like you to do this one tonight, and I'd like you to do the other 2 questions on the amusement park physics sheet and some multiple choice.